Hello everyone. So now sizothoma isection ye-trigonometry. So now i-approaches sizoyithatha ukuthi now sizofocus kuma question papers, right? So lapha mkwami ngine question paper laka 2010, it's paper 2. Sizo selector question 9 and question 10, question 9 and question 10, right? So my question with trigonometry, right? So they are out of 25 marks, and then when you do this under exam conditions, it should take you only 30 minutes to complete, yeah? So yeah, kubalulekile ukuthi practice under exam conditions ukwenzela ukuthi ukhona ukubona ukuthi mawufika ku exam uzokhona na ukuthi uliqede ipaper, or as u practice na uzokhona ukubona ama areas la kufanele uimprove khona. And yeah, okay, ngaphandle ukuthi simoshe isikhathi, let us look at question 9. So question 9 bathi given that tan alpha is equals to 3/4, where alpha is between 0 and 90 degrees, with the use of a sketch and without the use of a calculator, calculate sine alpha, right? So now, but with the use of a sketch, so which means kumele draw a sketch ukuthi sikwazi ukuthi sikhona uphendula kuhle these questions, right? So now sizoya lapha ku 9.1. We are given that tan alpha is 3/4. So if you remember from grade 10 trigonometry, naba introduce trigonometry on a Cartesian plane, we know what in the first quadrant all the trigonometric ratios are positive. In the second quadrant only sine is positive. In the third quadrant only tan is positive, and in the fourth quadrant only cos is positive, right? So notice ukuthi the value of tan alpha is positive, it's 3/4. So it means we are either in the third quadrant or the first quadrant, right? But then we have to be in one of these two. So to decide which quadrant we are in, we look at the value of the angle. The angle is between 0 and 90 degrees. So we know what that is in the first quadrant. It's between 0 and 90 degrees. So we have to be in the first quadrant. So now when we draw our sketch, just draw the first quadrant, right? Because tan is positive and the value of alpha is between 0 and 90 degrees. So now drawing our sketch, we'll have that tan alpha we'll have our right angled triangle, right? And then we'll have our angle alpha there, right? Tan alpha is 3/4. We know what from the definition of the trigonometric ratios, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent, right? So from this mnemonic usokatoa, you can remember the definitions trigonometric ratios, right? Again, remember what the hypotenuse is that side which is opposite the right angle, and then the adjacent side is the side which is next to the angle. The opposite side is the side which the angle is facing, right? So now because tan alpha is opposite over adjacent, and then we are told that tan alpha is 3/4, it means that here we will have 3 and here we will have 4, right? And then we can now calculate the value of our hypotenuse, right? So now sine alpha will be opposite, which is 3, and the hypotenuse is r. So we need to calculate our hypotenuse, right? calculating the hypotenuse, we'll use the theorem of Pythagoras, which says that the hypotenuse squared is equals to x squared plus y squared, right? We know x is 4 and then we know y is 3. Therefore, the hypotenuse will be equals to the positive square root of 16 plus 9, which is the square root of 25, which is 5. So now it means that sine alpha will be 3 over 5. And then now 9.2 but cos squared 90 minus alpha minus 1. And then so cos squared 90 minus alpha is the same as saying cos 90 minus alpha all squared minus 1, right? And then by using our reduction formulas, we know that cos 90 minus alpha is the same as sine alpha, right? And that is all squared. How do we know this? If cos 90 minus theta is equals to sine theta, you can test this. Say theta is equals to 30 degrees, right? If you say 90 minus 30 uzoba 60, and when you say cos 60, it will give you 1 over 2, right? So cos 90 minus 30 is equals to sine 30 into overlap, right? And then cos 90 minus 30, that is simply cos 60, right? And we're saying that is equals to sine 30. Cos 60, now press the calculator, you'll see that it's 1 over 2, and sine 30, you'll see that it's 1 over 2. So this statement here is true, right? Okay, loving Kazanje. It's reduction formulas from grade 11, right? So now we have calculated sine alpha already, and then we found that sine alpha is 3 over 5, and then we can calculate this by saying 3 over 5 squared is 9 over 25 minus 1, right? So this will be 9 minus 25 over 25, which will be minus 16 over 25. That is 9.2. Now 9.3. So ngizokusula la to create space for 9.3. Right? Okay, 9.3 batini. But calculate 1 minus sine 2a. Remember from sine 2a is one of the trigonometric identities, right? Now we are lapha ku formula sheet yakho uzobona ukuthi now we have a formula sheet uzobona ukuthi sine 2a is equals to sine 2a is equals to 2 sine 2 alpha, sorry, is equals to 2 sine alpha times cos alpha. So now going back to our question, ku 9.3 sizoba no 1 minus 2 sine alpha cos alpha, right? And then we know what sine alpha is opposite over hypotenuse. Hypotenuse here to be calculated with 5, and then sine alpha is 3 over 5. Cos alpha, we know what it's adjacent over hypotenuse, so cos alpha will be 4 over 5, right? So now this is over no 2 times 3 times 4 is 12, 5 times 5 is 25, and then sizoba no 1 minus 24 over 25, which is 25 minus 24 all over 25, which will be 1 over 25. Okay, that is 9.3. Now moving to 9 point. Oh, we are done with question 9. Moving to question 10. 10.1. Patini, you may not use a calculator to answer these questions. So again, last sizosebenzisa ama reduction formula. Now let's copy 10.1 to our whiteboard. Okay. So ku 10.1 but simplify completely, right? So to simplify completely, sizotoma lapha ku numerator. Sine 90 plus theta is the same. So now sine 90 plus theta. Again, lana e-cast diagram yako is very important, knowing that in the first quadrant all the trigonometric ratios are positive. In the second quadrant only sine is positive. In the third quadrant only tan, and in the fourth only cos is positive. So now sine 90 plus theta will be reduced to cos theta. So sine is positive. 90 plus theta, it means we are in the second quadrant, and then in the second quadrant sine is positive. So 90 plus theta is the same as saying cos theta. Again, you can test this by saying let theta be equals to 30 degrees. So sine 90 plus 30 is the same as cos 30 degrees. To prove this, you can sort of punch it in your calculator just to be sure. If you say sine 90 plus 30, that is square root of 3 over 2. And again, if you say cos 30, that is square root of 3 over 2. So this statement here is correct. Okay? So now, reducing the other trigonometric ratios, cos 180 plus theta. So 180 plus theta, we are in the third quadrant, and in the third quadrant only tan is positive there. So it means we will have cos being negative. So we'll have minus cos theta, right? Minus cos theta, and then cosine minus theta. So now sine minus theta is sort of like a reflection about the x-axis of this angle. So sine minus theta is in the fourth quadrant, and in the fourth quadrant only cos is positive. So they will have minus sine theta, right? And then in the denominator we have to reduce this using special angles. So 180 is a special angle. So now if you say sine 180, you will see that is the same as saying sine 180 is a special angle, sorry. So that is just equals to 0, and then tan, sorry, that's minus, tan 135 is the same as saying tan 180 degrees minus 45, right? Minus 45 degrees. And then using your reduction formulas, looking at the cast diagram, 180 minus 45 is in the second quadrant, and in the second quadrant only sign is positive there. So it means we'll have minus tan 45 in our denominator, right? Okay, let us simplify. In the numerator we still have cos theta. We have cos theta, we have minus low times no minus low will give us a plus, so we'll have cos theta times sin theta, right? And then in the denominator we'll have 0 minus tan 45, right? And then we'll have cos theta plus cos theta times sin theta divided by tan 45, right? 45 is a special angle, so from this triangle here we know what the special angles 45 and 90 will mean that the hypotenuse is equals to the square root of 2, and then the other sides are equals to 1 unit, right? And then if you say tan 45 here, you'll see we know what tan is opposite over adjacent, so that is 1 over 1, which is just 1. So it means in the denominator we'll will be dividing by 1, right? So then our answer will be factorizing cos theta. There we'll have cos theta times 1 plus sin theta, right? So now this is the simple form of this fraction here. That's okay. That's 10.1. Moving on to 10.2. Moving to 10.2. Right, so 10.2, but to prove that for any angle A, the left hand side is equals to the right hand side. So now the left hand side is this fraction and the right hand side is that one, right? So now I'll say the left hand side, the left hand side is equals to this fraction there. So now to simplify the left hand side, we have in the numerator we'll have 4 sin A cos A times cos 2A times sin 15 degrees divided by sin 2A, and then again going back to our formula sheet, we know what sin 2A is equals to 2 sin A times cos A. So there we'll have 2 sine A cos A, right? And then tan 225 is the same as saying 180 degrees plus 45, because 180 plus 45 is equals to 225 minus 2 sine squared A. Okay? Right, now looking at this, we'll see what sine and sine will cancel, cos and cos will cancel, and then we'll have 4 divided by 2. So we'll have 2 in the numerator. 4 divided by 2 is 2, so we'll have 2 cos 2A sine 15 degrees, right? And then divided by, in the denominator we'll have sine tan 180 plus 45. So again, looking at your cast diagram, 180 plus theta, we know what that is in the third quadrant. There tan is positive, so they will have tan 45 minus 2 sine squared A, right? And then we know what tan 45 is equals to 1, so we'll have 2 cos 2A sine 15 degrees is equals to 1 minus 2 sine squared A. Again, cos 2A we can find from our formula sheet. Cos 2A is either equals to cos squared A minus sine squared A, or 1 minus 2 sine squared A, or 2 cos squared A minus 1. So I will select this one. I will select this one here, this second one, right? I'll select this second one. So 2 cos 2A is equals to 1 minus sine squared 2A. So there we'll have, in the numerator we'll have cos 2A is equals to 1 minus 2 sine squared A times sine 15 degrees divided by 1 minus 2 sine squared A. Now this and that will cancel, so sizoba no 2 sine 15 degrees, right? But then as calculated, remember the goal is to prove that the left hand side is equals to the right hand side. So now sine 15 degrees, sine 15 degrees is also equals to sine 15 is equals to, is the same as saying 45 minus 30. So if you say 45 minus 30, you will get 15 degrees, right? Again, this we can use our formula sheet for this. So now look at this, sine alpha minus beta is equals to sine alpha times cos beta minus cos alpha sine beta. So ngizosebenzisa this identity here. So sizoba no 2 sine 45 degrees cos 30 degrees minus cos 45 degrees times sine 30 degrees, right? And then we know what is sine 45 is a special angle. So sine 45 is equals to 1 over the square root of 2 and then cos 30 is equals to the square root of 3 divided by 2, and then cos 45 is 1 times the square root of 1 over the square root of 2. Sin 30 is 1 over 2, right? So now if sin 1 over the square root of 2, this is also equals to more multiplier go square root of 2 ku numerator and denominator uzothola ukuthi this is the same as saying the square root of 2 over 2, right? So lapha sizoba no 2 times the square root of 2 over 2 times the square root of 3 over 2 minus the square root of 2 over 2 times 1 over 2, ne? And then the square root of 2 times the square root of 3. So okay, so if you have the square root of a times the square root of b, that is the same as saying the square root of a times b, right? So same thing applies na la ile question yethu. So lapha ku numerator yokuthoma sizoba no 2 times 3 sizoba no 6, the square root of 6 divided by 2 minus the square root of 2 divided by, oh sorry, then we sizoba no 2 times 2, which is 4. Now lapha sibe no 2 times 2, which is 4, right? Now ku numerator sizoba no the square root of 6 minus the square root of 2 divided by 4, right? And then we know what 2 goes into 4 2 times, so sizoba no the square root of 6 minus the square root of 2 divided by 2, which is equals to the right hand side. So we have proved this equation, right? If you khona la ungazwisisi khona ngicela ukuthi ungibuze lapho ku WhatsApp ngizama ukuthi ngichazele ngcono, right? And then moving on to 10.3 10.3, let us copy 10.3. Okay, so level 10.3 bathi determine the general solution of 6 cos x minus 5 equals to 4 over cos x not equals to 0, right? So now let us sort of try to get this equation in a simplest form. So to do this, I will multiply both sides of the equation by cos x, right? So in the left hand side, on the left hand side, I will have 6 cos squared x minus 5 cos x equals to 4, yeah? And then now I'll bring u follower to the left hand side also. So no 6 is over no 6 cos squared x minus 5 cos x minus 4 is equals to 0. And then uzobona ukuthi this is a quadratic equation, right? It's a quadratic equation if you let cos x be equals to m, so this equation will become 6 m squared. Where I see cos x, I will put m. So lapho ngizoba no 6 m squared minus 5 m minus 4 is equals to 0, right? And then now you can solve for this equation by either using the quadratic formula or by factorizing. So mina I will factorize, right? So if we factorize this equation, sizoba no 3m minus 4 times 2m plus 1 is equals to 0, right? So 3m minus 4 will be equals to 0, or 2m plus 1 will be equals to 0, right? Which means m will be equals to 4 over 3, or m will be equals to minus 1 over 2, right? But then we are actually solving for cos x there, right? So cos x will be equals to 4 over 3, or cos x will be equals to minus 1 over 2, right? But then as to solve for this equation, we need to find the general solution of this equation. In other words, we want the angles that will satisfy this equation. We want the values of x that will satisfy this equation, right? So in your calculator, if we for this part of the solution, if we take x equals to cos, and then now press the shift button and press cos, now cos inverse, and then uti 4 over 3, you will see uti for this case we won't have any solution, right? There will be no solution for this case, né? And then for this case we now have a solution for this case. But then the way we solve, the way engizoyisolva corner is to use a positive value for this trigonometric ratio to get a reference angle, right? So ngizosebenzisa u cos x equals to 1 over 2, right? Now for this sizothola ukuthi a reference angle yethu izoba ngu, the reference angle will be equals to cos inverse of 1 over 2. Uzothola ukuthi reference angle yethu izoba ngu 60 degrees, right? So now after having this reference angle senzani, we will then look for ama quadrants. Sizosebenzisa i-cast diagram in C, because thina sifuna the values of x which will satisfy this equation here. We want the values of x which will satisfy this equation here. We need to look at the, and then this value that we want to have when we substitute x is negative. We need to look at the quadrants where cos is negative, right? From the cast diagram we know that the first quadrant all the ratios are positive, second quadrant only sine is positive, third quadrant only tan, and then the fourth quadrant only cos is positive, right? Now we want the cases where our trigonometric ratio cos is negative. So lapho kusicela ukuthi siku second quadrant and then siku third quadrant. Notice ukuthi our reference angle is positive, it's in the first quadrant, right? But then tina sifuna the angles which will fall between 90 degrees and 270 degrees. So now to find those angles, sizoti in the second quadrant, using this reference angle, we know what x will be equals to 180 degrees minus 60, right? Plus k 360, where k is an integer, right? So in the second quadrant, this will be it will be 120 degrees plus k 360 degrees, where k is an element of the integers, right? So now that is the solution. So these ones will give us the solutions as over second quadrant. And then again, cos is negative with third quadrant. So in the third quadrant, we will have that x will be equals to 180 degrees plus our reference angle, which is 60 degrees, plus k 360 degrees, where k is an element of the integers, and then this over no x is equals to 180 plus 60 is 240 degrees plus k 360, where k is the element of integers, right? So this will be our solutions. This will be the general solution of the equation, right? Now to test this solution, take the values of k, take any value of k. A can be any value as long as that value is an integer. So let's take k to be equals to let's say 3, for example, right? If you take k to be equals to 3, kule equation le uzoba no 120 plus 3 times 360, 120 plus 3 times 360, uzoba no x is equals to 1200 degrees, right? And then if you say cos 1200 degrees, that will be equals to minus 1 over 2 still. So if you take k equals to 120 degrees, x will be equals to 1200. Sorry, if you take k is equals to 3, in the second quadrant solution, x will be equals to 1200 degrees, right? And then if you substitute cos 1200 degrees, you will still get minus 1 over 2, right? And then for the third quadrant solution, if k is equals to 3, uzothola x will be 240 plus 3 times 360. Uzothola x will be 1320 degrees. And then if you say cos 1320 degrees, uzothola that is minus 1 over 2 also. So yeah, this is our solutions. This one here, this one here, and this one here, right? Yeah. Okay, so we are done with this question. If unala ungazwisisi khona, ngicela ungazise lapho WhatsApp ngikhona ukuthi ngikuchazele kuhle. Okay.